So in the last video, so what we have discussed is how to calculate the syndrome word, right? Okay. Example, if we are storing the data bits into the memory, the check bit version 1 will be generated. If you are retrieving the data from the memory, then check bit version 2 will be generated. So check bit version 1 XOR check bit version 2, then surely we will get the result of syndrome word. So this is how we can calculate the syndrome word. Then now how we can calculate the check bits, right? Okay. So example, based on the reference, my check bit, right? Okay, so data bit size is 8, then surely my check bit size will be 4. So this is the reference, right? Okay, I'm just shortening, I'm giving the direct values. If my data bit size is 16, then surely my check bit size will be 5. Then if my data bit size is 32, my check bit size will be 6. If my data bit size is 64, then my check bit size will be 7, right? Now how we can position, right? Example, if I'm storing the data bit into the memory, how it will be stored? Data bit plus check bits. Okay, so this will be stored in the memory. This is how it will be stored, right? Okay, so now how it will be positioned. So example, if I'm having a data bit of, right? Okay, example here 0 0 0, then 1 0 0 1. So this is how, if I'm data bit, if I'm having. So for this I should have check bits of 4 is required. So how we can position the check bits, right? Okay, so example here 2 to the power of 0, then 2 to the power of 1, 2 to the power of 2, then 2 to the power of 3, like this. Okay, then automatically check bit 1, then check bit 2, then check bit 4, then check bit 8. So this is how the positions will be look like, right? Okay, so now here I need to place these positions in along with the data bit. Then how I can put the positions here? Then I'm starting with 1, then 2, then 3, 4, then 5, 6, 7, 8, 9, 10, 11 and 12. So this will be easy. So easy to understand, right? Now here you just see that I have placed this check bit position 1 in the position 1, check bit 2 I just positioned in 2, check bit 4 I just positioned in 4th position, check bit 8 in 8th position, right? Now remaining positions I can put the data bits, right? Here data bit 1, then data bit 2, data bit 3, then data bit 4, then data bit 5, then data bit 6, data bit 7 and data bit 8. So how we can position it here? So data bit 1, data bit 2, 3, 4, 5, 6, 7, 8, right? This is the data bits, right? Data bits. Okay, so how we can fill it here? Here I can see that 1, then 0 0, then 1, then 0 0 0 0. So this is how I can place the data bits inside the bit positions, right? Now I need to calculate that what is the value of check bit position 1, then check bit value 2, then what is the value of check bit 4, then what is the value of check bit 8. But if you are checking the William Stallings theory book, Computer Architecture, Organization and Architecture book, if you are checking, there is a formula. But before going into the formula, then if we are able to understand how they are calculating the formula, then it will be easy, right? Okay, so now you need to understand that if I wanted to calculate or check or verify the check bit position 1, I need to start from the position 1. Okay, how can I do it? I need to check 1 bit and leave 1 bit, and check 1 bit, leave 1 bit, check 1 bit and leave 1 bit, check 1 bit and leave 1 bit. Wherever I'm checking, if the value is there, I need to take it, right? Okay, but here for the check bit position 1, I'm just checking, but there is no value. But if I'm checking the value of data bit 1, there is a value. And here also I'm just leaving and checking, the value is 0 here. And leaving, I'm checking, and here the value is 1. Then again like this, right? Okay, here also I need to check it, then leave, check and leave. This is how, right? This is a value, that is a check bit position 1. I can calculate like this. If I wanted to do the check bit position 2, I need to start from here. I need to start from check bit position 2 here, because I need to start, I am just going to find out what is the check bit value 2. So here 2 bits I need to verify. So check 2 bits, leave 2 bits, check 2 bits and leave 2 bits, check 2 bits and leave 2 bits, like this. Okay, now because here check bit position 1, I need to start from position 1. For check bit 2, I need to start from check bit 2. If I wanted to calculate the check bit number 4, I need to start from check bit 4. Here I need to verify the fourth position. I need to check 4 values, right? Check bit 1, 2, 3, 4 and leave 4 bits. Again, I need to check 4 bits, like here if the value is there, I can check it, right? So this is how I can calculate the check bit position 4. Now you just guess that how we can calculate the check bit position 8. Now, because here the check bit position is here 8. So now, previous for fourth position, right? Check bit 4, we have verified continuous 4 bits and leave 4 bits. Continuous 4 bits I need to check, then leave 4 bits. Now for check bit position 8, I need to check 8 bits, right? Okay, 1, 2, 3, 4, 5 and 6 only. The 6 positions are there, I need to check 6 only. But if the data bit size is 16 instead of 8 data bits, then if I'm having a 16 bit data, then surely it will go. Right? This is how I can go with the, now you just see that we have checked how we can calculate the check bit 1 and check bit 2 and check bit 4 and check bit 8, right? Okay, so you need to understand that now we have seen that how many check bits can be calculated for data bit size. If the data bit size is 8, my check bit values will be 4 check bits I need to calculate. Then if my data bit is 16, then my check bits will need to be 5. If the if my data bits is 32, then my check bits values will be 6. So 6 check bits I need to calculate. If my data bits are 64, then surely my check bits need to be 7. But likewise here I have mentioned that up to 8. Right? Then after this, how it will be? C8. Then automatically it will go to the 16, C16. That's why if I'm having a 32 bit, then how many check bits will be here? So C1, C2, C4, C8, then C16. Right? C16. But if the check bit position, here you just see that 5, right? Here 16. Sorry, for this one, right? 16. If my data bit size is 16 and these are the 5 check bits, right? 5 check bits. If I'm having then 32, surely I need to go with the 6 check bits, then one more will come here, right? C32 will come, right? So this is how I can calculate or understand the data bits along with the check bits, right? Okay. So in the next video, what we can do we will take one example, then how we can calculate the check bit version 1, then check bit version 2, then how we are going to do the XOR operation, then how we are going to calculate the syndrome word, right? This one we will discuss in the next video, right?